Perfect bike is hard to create. Does it exist? Potentially.
We don't want to create the lightest bike in the world or the most aerodynamic bike in the world. We want to create the bike that gets our riders to the finish line first.
I don't care what the weight is, I don't care what the aero is, I just want to get there as fast as possible.
At the end of the day is just getting the rider to the finish line first.
The only goal we have in mind is winning races. Because at the end of the day, our only goal for this product is to make the fastest bike in the world.
Equation of speed is the baseline for all of what we do on bike like Tarmac. We take a look at slope distribution of the Grand Tours of the last 5 years. We look at wind speed distribution within those certain areas of the world where we want the bike to perform. We look at power output of a rider, and then we take all those inputs into the equation of speed, and we can tweak the numbers of the bike. So we can say, okay, we make the bike 200 grams lighter, but we make it 2 watts slower. How is that affecting the time to finish? Or we keep the bike weight as it is, but we make it X amount watts faster. How much faster do the riders get to the finish line?
When we run CFD simulations and we see that a certain setup helps us to improve one kind of aerodynamics, but we know it is technically not possible to make this shape without adding 100 grams to the frame. We can already raise our hand and say, hey, if this is more than 60 gram cost, then in average it's gonna be slower. And this is a level of resolution we are developing, and I think it's something to be proud of.
The equation of speed is our North Star within development. We're not trying to make a bike that just wins from an air perspective in a wind tunnel. We're trying to make the fastest platform for our racers over race courses.
And time to finish is what we want to minimize for.
And without the equation of speed, you're just kind of guessing. The equation is the only way we can take all these different distinct variables and actually say with certainty, we are making the bike faster, we're making the whole platform faster.
Setting goals for a project like this, a bike where you can't compromise, we knew that Tarmac SL8 could already easily be built to the UCI weight limit of 6.8 kg. We know that it's one of the best riding bikes in the pro peloton, but we knew that with the road racing speeds just going up since Tarmac SL8 launched, many of the competitors are on dedicated aero platforms.
The minimum requirement is get this bike at least as good as SL8, as light as SL8, as stiff and compliant, but let's make it faster.
The most difficult process is in the concept phase. We are a group of people who really loves to pushing the boundaries. So when you walk into a meeting like this, you're not just reviewing about the data, the timelines, you are really talking about how to make the rider faster on the biggest stage in the world. Also, we need to meet pro racing team's requirements. So the scope gets bigger and bigger over the time. I would say this is probably the most complex project I ever made.
It does put quite a bit of pressure on the team when the priorities are have the same weight as SL8, have the same ride quality and compliance characteristics of SL8, and also make the bike 4 watts faster. That's essentially asking them to make the impossible possible.
I mean, making this bike as light as SL8, designing a layup, being able to sort of recover weight here and there to allow for aero features that consume weight, well, that was a real challenge for the simulation team.
The biggest thing that came up to us was mostly around down tube and front end to start, because you have to fix the front of the bike before you can work your way backwards. The first prototype we did for SL9 was actually the rear end off of a used old race bike SL8, and then we put on a machine skeleton on the front that we could then bolt on different shell pieces. So when we talk about the fork shaping, the down tube shaping, a lot of that stuff was really refined and fine-tuned in CFD. Run a bunch of different shapes, different geometries. We make 3D prints, we make machine prototypes, we bring those into the wind tunnel, and then the wind tunnel is our final gold standard on what works and what doesn't. We have put countless and countless hours of work into trying to develop the most realistic and repeatable possible way to quantify the aero performance of bicycles. As we get more and more into marginal gains, we know that we have to be both as realistic and as repeatable as possible.
Within the development of Tarmac and every other bike we're working on right now, we have the riders really placed at the center of the ecosystem. All of our development is focused with using our moving leg mannequin. As we develop product, we also continue to develop our mannequin setup as well. We have developed our latest generation specifically around the development of Tarmac SL9.
When we first started working with mannequins, they were static mannequins, right? They just sit still in the wind tunnel, they don't move. The legs are always in the same position. We did a lot of simulation studies in CFD, and it's very clear that the interactions of the mannequin with the chassis do depend on where in the pedal stroke you are. The new mannequin was a huge part of the SL9 project because with SL9 and the equation of speed, we know what the key moments we're trying to focus on are, and we're trying to make sure that we're capturing how the bike is used in those key moments as realistically as possible. The longer we work on these bikes, the more we fine-tune them, the more we improve our methods, right? So with each generation of Tarmac, we have improved the quality of testing, and we've improved the quality of testing that goes into developing the chassis. SL8 was our first bike with a pedaling mannequin. SL7 used a static mannequin. SL6 didn't use a mannequin. So with each new Tarmac, we're doing a better, more realistic job of developing the chassis. The more realism we can add to how we develop our products, the better they work in the real world.
But that is the key piece for us, is we're developing a system around a rider, not just developing a system on its own. We want to make it as realistic as possible when we're looking into time to finish. And we have a team that does an insane amount of analysis for that. We're looking at surface roughness, wind speed, rolling resistance, the aero aspect of the platform, the weight of the platform, what the power is that riders are putting out on certain climbs or certain stages overall, the actual speed that those races are occurring at. All of that goes into time to finish to help us develop the fastest bike possible.
It's completely different racing nowadays, so knowing that the guys are really looking at race situations and looking really deep into how a frame should be built, it's pretty cool to see all these little adaptations everywhere, which makes the bike completely different.
If you look at the pinnacle of motorsports, especially Formula One, no single decision matters without its impact on lap times. That is the same thing that we are doing here. It is, how can we deliver a product that gets you to the finish line the fastest? I don't care what the weight is, I don't care what the aero is, I just want to get there as fast as possible. What decisions get me there as fast as possible? So there is no room for interpretation by engineers or by product managers. There is no lack of clarity as to your targets or your goals, because we only have one goal: get to the finish line as fast as possible.
We're not developing the bike to sit in the peloton. We're developing the bike for race-winning moments when it matters the most. With SL9, every aspect of the bike is updated. Every tube profile, tube shape is updated compared to SL8, but everything from the top tube, seat tube, it's all developed to go faster.
One of the really big ways we move the needle from SL8 to SL9 is the head tube width. This is the narrowest head tube we've ever had on a road bike. A lot of ingenuity and engineering went into the internal system to get that extra width out of the head tube, and every millimeter we can get that head tube narrower really helps us move the needle on performance.
Some plies are merely structural. Some plies just provide a shape, and that is for aero performances. The wind fin, it's there to make the bike faster and to guide the airflow, but it doesn't carry load.
We continue to learn more and more about how that rider and bike is a complete system. One of the key pieces that we learned for SL9 is just how much more the air is accelerated between the rider's legs. When we found that out, we definitely wanted to take advantage of that.
We have a super narrow flag section on the seat post because as the airflow accelerates through the rider's thighs, the seat post sees one of the highest flow speeds of any point on the bicycle. So really narrowing that down as much as possible goes a long way to improve the aerodynamics working with the rider.
One of the feedbacks from our pro athletes that in key race scenarios, they ditch their seat tube bottle.
And those athletes in those key situations, let's say like a Demi or a Remco in a solo break, most of the time or at the end of the race, they are only down to one water bottle on the down tube.
So the seat tube shape actually gets much more important.
Almost all the aero testing is with one small bottle in the front, no bottle in the back. It's just about being as realistic as we can to best serve our riders. Something that's really unique and new on SL9 is actually our fork blades twist inwards. The way they twist inwards is to manage airflow where the wheel meets the down tube. This works super well for us because we control every single component in that flow path. We are developing all of these products as a family, which gives us huge opportunities for synergy between the components.
Throughout the process, we're getting feedback on what we're developing, but it is really fun when we finally get to show the teams and athletes the final product. Really the fun part is when we actually get athletes on the bikes.
It's designed to be more aerodynamic. Post, everything is like really made to be fast, and yeah, you can actually feel that when the bike is rolling, it's really rolling. So combination of tires, frame, it's all very smooth and very fast. So yeah, very happy.
I really like the one-day races, so I would really want to race it on the one-day races as well. It would be really good for some sort of classic racing. You know, classics is chaos, and the SL9 feels like it's ready for chaos.
There is a human aspect which is, for an engineer, hard to put into an equation. This is where the input from the team is absolutely crucial for its development. It would not be possible without the teams.
It's not just previous generations of Tarmac that go into every new generation of Tarmac, also projects like Athos and Shiv, where we take all of the different learnings and we then apply them to Tarmac. I would say it's a little bit like with genetics within Specialized. All of the bikes are kind of linked. Inside the DNA of a new Tarmac, you also have all of the DNA of the other bikes within Specialized.
You could see some of the TT aerodynamic features from the Shiv in this new bike. It reacted immediately to your power output. You could almost hear it cutting through the wind, you know. I really like that. This is a part that I find super important, especially in a race like Amstel Gold Race. Having this race situation where you want to attack and finish solo like I did last year, it's just nice that you know you have a bike suitable for different scenarios in the final.
I was not sure how to make a bike even faster as the SL8. It's a really good bike. I felt directly when I was riding outside, it's handling a bit different. Also like the power output when you're standing up in the pedals. You feel like the power goes straight into the pedals. You want to go fast, the bike is going where you want to go. It's even, again, a better bike. It's really cool.
When we look at the equation of speed, right, in terms of how much weight do we have to add to this chassis to substantially move the needle of aerodynamics, that leads us to one conclusion, which is one bike to rule them all is our solution. The ability to redefine and refine what that means in terms of performance is one of the most exciting things we can do.
We managed to improve the best bike in the world.